Hello everybody, this is Rudra Pradhan here. Welcome to BMD lecture series. Today we will continue with prescriptive analytics and that too coverage on dual simplex mechanism. We have solved couple of problems and that too highlighting primal structure, dual structure and looking for the optimal solution, and the solution which we have already highlighted in the context of primal problem. So, that means corresponding to a particular business problem, whether it is a bivariate structure or multivariate structure, that would depending upon the number of decision variables or number of constant in a kind of system or in a kind of problem. So, we like to choose a particular technique. In fact, programming and the solver will not actually the kind of requirement of whether it is a bivariate structure or multivariate structure, but when we manually handle the business problem, then we have two different structure to to get the kind of optimal solution. For instance, if a particular primal problem is with respect to two variables and two constants or two variables with more number of constants, then simple graphical structure we can apply and look for the optimal solution, that to address the business problem as per the particular management requirement. So, now if a problem having let us say more than two decision variables, then a graphical structure cannot have a kind of structure through which you can get the optimal solution. In this context, we can apply simplex method through which you can get the optimal solution or the values of the decision variable. That means simplex method means it is a algebraic method through which you can look for the optimal solution. That means we will move for one iteration to another iteration and continue till you get the optimal solution. So, now what is happening here, if you have a two variables and more number of constants, then you can start with graphical structure through which you can get the optimal solution. But when we have a more number of variables, then irrespective of the kind of constants, number of constants, then by default we will go to the simplex mechanism through which look for the optimal solution. Whether of course through solvers there is no such requirement, but still you have to understand the situation and look for the optimality. Now, means the point which I like to address is like this, why there is a requirement of duality corresponding to the primal kind of structure. For instance, if a primal structure is having two variables with the three constants, then easily you can actually you can apply graphical structure to look for the solution, and then its counterpart dual will be again three variables with the two constants, which may be little bit complex. Now, if a problem is having let us say three variables with the two constants, then the counterpart dual problem will be two variables with the three constant. In this case, we can simply apply the graphical structure. So, that means technically the primal structure where we cannot easily apply the graphical mechanism to get the optimality or to get the values of the decision variable, but in the if you go for the dual transformation, the same problems can be give you the optimal solution, and that too by the application of graphical mechanism. So, obviously, we will see how is the particular structure and then look for the optimal solution. Sometimes if the primal is complex, then the dual may be little bit simpler to address the problem, or if it is a dual is a kind of complex, then the counterpart primal will give you the kind of simple structure through which you can address the business problem more effectively. And so, we have two different structure altogether corresponding to the primal. So, the mechanism which you can apply called as simplex, that is called as a primal simplex mechanism, and then corresponding to the dual, then the mechanism which will apply called as dual simplex mechanism. So, here we like to see what is the dual simplex structure through which you can look for the optimal solution. In fact, in the first and whatever problems we will have, so we can start with primal simplex structures, you can start with dual simplex structure, but there is a typical difference. Ultimately, we will reach the optimal solutions. Here the start of the particular process in a kind of setup, but the counterpart will be having different kind of setup. For instance, in the case of primal simplex methods, we start with the means you set all these things, then after setting the initial basic feasible solution or initial basic feasible matrix, then you will check for the optimality. If you reach optimality, you stop and address the business problem accordingly. If you have not reached the optimal solution, then you go to the next iterations, and the procedure of movement from first iteration to second iteration or initial step to next step depends upon the requirement of incoming indication and the outgoing vector indications. So, in the primal structure, the first hand requirement is to find out which variable will be the incoming into the basis matrix, and then looking for the outgoing vectors. So, that means, if there are 3 variables and the basis matrix depends upon which particular variable will be replaced with which particular variable. So, that is how we look for incoming vector first, that will give you the particular indication that that particular variable should be into the basis matrix. Then again we will look for the outgoing vector, where that particular indication will give you which particular variable will be out in the basis matrix. That means, the incoming vectors will be in place of the outgoing vectors. So, that is how the structure of primal simplex method, and the corresponding dual simplex methods we start with just opposite opposite direction. So, that where we first look for the outgoing vectors, and corresponding to the outgoing vector we look for the incoming vectors. So, so that is how there is no typical drastic difference between these two mechanisms, only the entry of incoming to outgoing and then outgoing to incoming. So, then the incoming outgoing intersections will give you the pivot element, and through which the entire structure will change, then we will finish up the particular iteration, and again look for the optimal test. If you reach the optimal structure, then you stop and address the business problem and come with a kind of management decision. If not, then again we continue the particular procedure. Go to the second step, again we go follow the similar kind of structure, go for the testing. If you reach the optimality, that means the indication of the optimality, then stop there and again address the business problem. If not, again you repeat the same process. That means, it is a kind of continuous process, and each steps you will get the improved basic feasible solution, that to values of the objective function moving from first iteration to second iteration and so on. So, that is how the beauty of the primal structure and the kind of dual structure, that to primal simplex mechanism and dual simplex mechanism. Let us see how is the dual simplex structure altogether, and how is the indication of incoming vector, how is the indication about the outgoing vector, the way which you have already addressed in the case of primal simplex method in the last lecture. And in fact, in the dual simplex methods we have also similar kind of setup, but only thing is that we like to know what is the indication of incoming vector and the kind of outgoing vectors. Of course, the starting process is from the outgoing to incoming vector, and then we look for the optimality, and then finally we will proceed till we get the optimal solution as per the particular LP structure or the kind of prescriptive analytic structure. So, let us see here the kind of dual simplex mechanisms. So, simplex mechanism and dual simplex mechanisms. Simplex method starts with a non-optimal, but feasible solution, whereas dual simplex method starts with an optimal, but infeasible solution. So, that means, it is just counterpart kind of things through which you can address the business problem, and simplex method maintains the feasibility during the successive iterations, whereas dual simplex method maintains the kind of optimality. And so far as the stepping is concerned, so the first hand requirement that all the constraints except those with equality signs are modified to make less than equal to sign, and constants with greater than equal to sign are multiplied by -1 throughout, so that the inequality sign gets reversed. Finally, all these constants are transferred to equality signs by introducing the kind of slack variables. So, that means, This is the typical requirement of dual simplex mechanisms, and once you acquainted, then you can actually follow the iterative process till you get the optimal results, right. So, in the modified problem, like with respect to the step 1 is expressed in the form of a simplex tables. If all the cost coefficients are positive and one or more basic variables have a negative values, then the dual simplex method is applicable. So, that is the first hand requirement of entering to the dual simplex mechanism. For instance, like primal to dual transformations. So, we do the transformation, and while doing the transformations you maintain a kind of consistency having the with respect to the kind of constraints, and the procedure of dual simplex method is like that at least one of the right hand side of the constant should have a negative signs after the transformations. If that is the case, then dual simplex method can be applied, and then you follow up the iterative process and the kind of search for optimality till you get the optimal solutions or the kind of indication about the infeasible or unbounded or multiple. So, whatever may be the kind of scenario, but ultimately this is what the starting procedure through which you look for the optimal solutions. Then accordingly the selection mechanism will be like this: selection of existing variable. The basic variable with the highest negative value is the exist what is called as outgoing variable, and if there are two kind of situation for kind of living vectors, and new one can be selected. The row of the selected exiting variable is marked as pivot kind of row. That is what actually the kind of indication. And then selection of entering variable, that is what is called as an incoming vector. So, that typically depends upon the cost coefficients corresponding to all the negative elements of the pivotal row, and that to that to be identified, and their ratio are calculated after changing the sign of the elements of pivotal row. That is, the column corresponding to minimum ratio is identified as the pivotal column, and associated decision variable is the entering variables. So, this is what the kind of transformation which we like to have here, and so obviously, so the first hand requirement is the transformations as per the dual simplex requirement. So, after doing the dual transformation requirement and then check the coefficient of the constant that to right hand side, and then look for the outgoing indications, and corresponding to the particular outgoing indications we look for the incoming indications, and for that we need to have actually cost coefficients and the values of the decision variables corresponding to the incoming vector row. Okay, so, that is how the kind of requirement. So, then we look for the kind of solution. So, let us see here how is the kind of solution. So, the key operation is exactly same as in the case of simplex mechanism. So, that means technically in the case of primal, so incoming vector and then outgoing vector, then the key element, that key element will be the unit matrix format, and accordingly we will change the ordering and look for the optimality. And again in the case of dual simplex methods, this is also similar procedure, only difference is we start with the outgoing first and then incoming second, while in the case of simplex mechanism we look for incoming first, then looking for the outgoing second. Ultimately, the pivot element will be in the similar kind of indication. So, you start with the incoming and outgoing, again we start with the outgoing and incoming. So, the intersection point will be treated as pivot point through which the entire iterative process will again give you the kind of structure through which you can look for the improved optimal solution or improved basic feasible solution through which you can address the business problem, provided so that particular step should be the optimal step. If not, then you will again move forward till you get the optimum solution as per the particular business requirement. So, now so check for optimality is if all the basic variables have non-negative values, then the optimum solution is reached. Otherwise, we will continuously move from step 3 to step 5, and repeat the process till you reach the optimum solution or some kind of indication about the unboundedness or some kind of infeasible solution or some kind of multiple solution. So, now let us start with a simple kind of examples. Let us say this is a problem, so which you have actually minimization type, and that too minimizing z equal to 2 x 1 plus x 2 subject to x 1 greater than 2 and 3 x 1 plus for x 2 less than equal to 24, for x 1 plus 3 x 2 greater than 12 and minus x 1 plus 2 x 2 greater than 1. So, that means we have two variables and 4 constraints, and some are less than type and some are greater than type. So, now we like to solve this problem in a kind of dual simplex mechanisms. In fact, we can solve this problem in a kind of primal simplex mechanism, where we will start with the initial basic feasible structure, then look for the incoming vectors and the outgoing vector. That means, the kind of basic metric structure through which you can reach the optimality, and we will continue the procedure by searching incoming, outgoing, and then we reach the optimal solution and the values of the decision variable through which you can address the business problem and the kind of management decision. And in the case of dual simplex mechanism, the procedure is more or less same, where the iterative process will follow from the outgoing to incoming, then the kind of structuring and restructuring till you get the optimal solutions as per the particular business requirement. So, now corresponding to this business problem and the particular first hand problems. So, we will move how you can go to the dual simplex procedures. See here, this is actually minimization type, that is the with respect to two variables and subject to 4 constants, and where 3 are greater than type and 1 is less than type. So, now after transformation. So, that means, the first hand transformation is make the constant into equality by introducing slack and surplus variable wherever it is required, and then look for the solutions. So, what we have done here? So, we actually transfer all the constant into a particular shape by changing the sign of the structure. For instance, here x 1 greater than 2. So, what we can do? We can put minus x 1 less than equal to minus 2, and then we can add a slack variable to address the kind of situation. That means, we transfer all the constant into less than type and then introduce the kind of slack variable through which you can actually address the business problem as per the particular requirement. So, now the objective function structure is more or less same here, and then the constants, these are all called as the kind of added variable through which actually we can address the dual simplex mechanism. So, the first and dual simplex mechanism as after the transformation is at least one of the b coefficient, that is the right hand side of the constant should be -1, and that will give you the indication about the outgoing vector, and after that we will calculate the cost coefficient and then look for the incoming vector, then look check the optimality. If you reach the optimality, you can stop and address the problem or interpret the problem as per the management requirement. If not, then again you move to the second step, again you look for the outgoing vectors, incoming vectors, and again check the optimality, and then look for the optimal solution and values of the decision variable. So, that means again it is a kind of continuous process, like simple primal structure, that is the primal simplex mechanism, and a dual simplex mechanism also more or less similar kind of iterative process or the kind of continuous kind of improvement through which we will proceed and to get the optimal solution to address the same business problem as per the typical requirement. So, now corresponding to this, so this problem, so this is how the first step of the process for the dual simplex methods. Then we develop the kind of matrix, and that too So these are the following variables. So means which one will be the basis matrix, that depends upon the unit matrix. So that means technically, so x3, x4, x5, x6, these are all so here. So these are all actually designed to have a for basic matrix, and that is the unit matrix. So as a result, in the first and initial setup, so these are the entries to the basis matrix and to the kind of optimal solution. And as a result, here x3, x4, x3, x3 the kind of structure, and the kind of structure here. So, okay, so this is what the kind of structure. So the x3, x4, x5 and x6, and then look for the kind of solutions. Obviously the solution will be here. Okay, so obviously, so x3, x4, x5 and x6, these are the basic variables, and then accordingly these are the input coefficients, and x3, x4, x5, x6 are all unit matrix, and then this is what unit matrix structure. And obviously first hand requirement is here the kind of outgoing variable indication, and then we can look for the kind of solutions, that too highlighting the kind of indication about the incoming vector. And okay, so this is what the that means technically x5 is the indication about the outgoing vector. So that means we have actually three coefficients, b coefficient, that is negative. So we will take most negative value, that is here x5, that is -12 compared to -2 and -1, and then means that is the indication about the outgoing vector. And again, so we look for the incoming vector. For that, we like to find out the ratio, which depends upon the cost coefficients divided by the kind of elements of the outgoing vectors, and then look for the kind of best answer. In this case most negative, and in this case again maximum value. So means this is the kind of indication through which you can get the kind of indication. So here it is a kind of most negative, and this is how the kind of minimum ratio through which you can get the pivot element. And once you get the pivot element, so that is the indication about the kind of unit matrix. And again the adjustment will be x2 will be coming in the place of x5, and x5 will go to the kind of position of x2. So so this process will continue till you get the optimum solution where we will address the business problem. And accordingly the second iterations, so this is what the first hand iterations. And so after the first hand iterations, the typical structure is x2 will be coming in place of x5, and x5 will go to the place of x2. Then you will address the kind of structure, again look for the optimality, and then accordingly you move to the second step here. In the second step, that is the improved versions after the first iterative procedures, and here we have only one negative v, that is with respect to x3. So by default that will be the outgoing vectors, and that will be the outgoing vectors, and then we look for the incoming vectors. And here there is only one case where we can get the kind of incoming vector, because in other case the coefficients are not actually negative. So as a result, by default this will be the incoming vector. So that means this is a kind of unique scenario here, only one negative. So by default that will be the outgoing vector indication, and here it is the only one ratio through which you can choose the incoming vectors. So by default the indication is that x1 will be coming in place of x3, and x3 will go to the place of x1s. Then again you change the typical structures and complete the iterative process. Okay. So after doing the iterative process, then we move to the next table, that is the third successive iterative procedure. and here again like the previous case we have only one negative B coefficient, and that too in place of x 6. So, by default x 6 will be the outgoing vectors, and again corresponding to the minimum ratio means the cost ratio between cost coefficient and the outgoing variables indications. So, only one ratio is actually coming here, because x 5 is having only negative value. So, again it is a kind of unique here, no extra kind of effort required. So, here this is the indication about the outgoing, and this is what the indication about the incoming. So, that means technically x 5 will be coming in place of x 6, and x 6 will go from the basis matrix, and that too in place of x 5. Again complete the iterative process by putting the pivot element 1 and remaining element 0, and then move to the successive iterative process. And here after third iterations we will find all the coefficients of B are coming positives. So, that is the indication of dual simplex optimality. So, that means we start with the initial basic feasible solution and then move in a kind of iterative process where all B will be coming positive. So, that means we can apply dual simplex after the kind of transformation, first hand transformations, and we can move to this particular process, that is the dual simplex process. So, with the condition that at least one of the B coefficient, that is the right hand side of the constant, should be negative, then you move on in a kind of an iterative process till you get optimal solution. So, the reach point of the optimal solution is like that all the B coefficients, that is the right hand side of the constant, should be positive, and corresponding to this problem. So, the problem is here. So, the corresponding to this problem, this is the first hand transformations, where we have a two negative values of the B coefficient. Then in the first this is two in the first iterations. So, we have actually three negative coefficients, and in the second iterations we have one negative constant coefficient, and again in the next step we have again one negative B coefficient. So, that is how we can we are means that means we are in a position to find out the kind of outgoing and the kind of incoming. So, again in the final so that means in the this particular step, which you can call as a final step, or the that means declaration of the optimality, because we have the reached the condition where all the B coefficient, that to right hand side of the particular constants are positive. So, that means this indicates that we have reached the optimal solution, and obviously in the basis matrix in the final optimal solution we have x 1, x 4, x 2 and x 5, and corresponding to the particular B indications. So, the x 1 value is equal to 2 and x 2 value is equal to 1.5, because x 4 and x 5 originally not in the original problem. So, these are all kind of slack and or surplus variable through which you can start the process to get the optimality. And since the problem is with respect to x 1 and x 2, and obviously x 1 is giving to optimal value of 2 and x 2 is giving the optimal value of 1.5. Now, you put this value in the objective functions, and then the value of the z will be coming 5.5, which we will have here actually, that is the z indication, and that means technically we have reached the optimal solutions, and that is in the process of dual simplex mechanism. So, solution of dual from primal simplex is so that is to start with maximizing objective function with less than type of constant, 3 less than type of constant, then the typical structure will be like this. And now, corresponding to the dual simplex structures, you can do the kind of adjustment, again look for the optimal solution. In fact, more or less the typical kind of iterative process is more or less same. Only thing is the choice of the incoming vector and the outgoing vectors. Obviously, there is no issue about the kind of incoming and outgoing mechanism. Here the idea is corresponding to a kind of business problems, we look for the optimal values of the decision variable through which you can address the business problem more effectively, more efficiently, and whether you apply actually simple kind of primal simplex structure or dual simplex structure, that is not a kind of issue, but ultimately we should have a kind of optimal solution through which you can address the business problem, because our ultimate idea is to look for the solution to a kind of business problem. Whether you follow the primal simplex structure or dual simplex structure, that is actually not a kind of issue, but ultimately we should have optimal solution through which you can solve the business problem and come with a kind of management decision as per the particular requirement. So, obviously, so corresponding to this problem, primal problem, so our dual structure will be like this, and again, so the final solution will be lying here only, and that too x 1 is equal to x 1 equal to 14 by 9 and x 2 equal to 8 by 9 and x 3 equal to 22 by 3. So, this is what actually the kind of game between a primal. So, this is what actually the kind of transformations here y 1, y 2 and y 3. So, the first end is the dual primal indication x 1, x 2, x 3, x 4, x 5, x 6, and corresponding to this primal maximization z and that too subject to constants. Since there are 3 constants, so we have a 3 unit matrix, that is x 4, x 5 and x 6, and again corresponding to this dual problem will be y 1, y 2, y 3, and as a result this x 4, x 5, x 6 will be having actually kind of dual transformations, and that too. So, the value of the objective function and the z is coming actually 22 by 3, and that is how the kind of game between primal simplex method and the kind of dual simplex method. So, that means typically in this particular lectures we have discussed a kind of concept, that is the dual simplex method, which is a kind of alternative tool to a kind of problems where we have already applied primal simplex method and look for the kind of optimal solution to address the business problem. Now, dual simplex method is a kind of alternative mechanisms which can address the same problems in a kind of different angle altogether, but ultimately we will have a solution for a particular business problem, and that too look for the kind of management decision. The way which we have already highlighted, if the primal is having optimal solution, the dual can have optimal solution. So, that means if you have primal problems and applying simplex methods and if the problem is consistent and getting the optimal solution, obviously the same problem if you apply through dual simplex methods, you can also have the optimal solutions, and whether you are getting the solution through primal or getting the solution from the dual simplex method, we have no business. Ultimately, we need actually solution through which you can address the business problem and then come with a management decision as per the particular business requirement. And so far as post hoc analysis is concerned, we can also go for the sensitivity structure, then the kind of change of the particular requirement, like the change of the coefficients of the objective functions. You can go for adding more constants, dropping few constants, and change of the right hand side of the coefficient, left hand side of the coefficient. That means technically since business is very dynamic, so these changes are always there, and depending upon the original situation and the change situations, we can also have the kind of flexibility and look for various alternatives depending upon the change situation, and we through sensitivity analysis we will get optimal solution again with respect to the changing situation, and then that will give you more practical or more value addition to the business problem, through which you can analyze the business problem more effectively and more efficiently. And with this we will stop here, and thank you very much. Have a nice day.